Hello, my name is Daniel Edgar. I'm a technical product manager for F5 working in the NGINX business unit. This video is going to be the first in a series of videos that focus on NGINX App Protect policies. What is a policy? Well, it's really the configuration that reflects the protection that you want applied to your application. You can define a specific policy for your application, whether it's JSON, XML, gRPC, that's appropriate. But also important to a policy is the amount of security you want to be able to apply to that. One of the benefits of NGINX App Protect is this policy we talked about, you own entirely. Very specifically, it's a JSON file expressing the features that you want to be able to turn on or turn off in your security policy. This is important because in many modern application delivery pipelines, you very likely have a CI/CD or automated pipeline to deliver your application into target environments, such as production. You probably have your code base or your configuration, whether it be infrastructure or the application itself, in some sort of a source control management tool, such as Git. NGINX App Protect's policy, being a JSON file, fits very well within that type of a workflow. You can deploy this file along with your configuration management, your application code to the target environment that you wish, ensuring that you're going to have consistency in functionality and assurance of security efficacy once your application goes into production. Out of the box or at installation time, NGINX App Protect supports a number of security policy features, which we're going to briefly cover right now. Attack signatures, which represent attack patterns that can be carried out against applications, such as many of the popular items that are on the OWASP top 10. You may have heard of that before. There are signatures that apply to specific technology stacks, which you can further tune your policy based upon your application stack. So NGINX App Protect can work optimally to provide protections and responses and telemetry for your given application stack. There's also the threat campaigns feature, which is a set of patterns that you can apply on a regular basis to help defend against attacks that are going on in the internet. Important to every web application firewall product is HTTP compliance. Being able to enforce what a proper request and response looks like is important. Also, the ability to protect against evasions, whether an attacker is trying to hide nefarious payloads via other encoding sets or multiple encoding. It is important that we be able to detect and block those kind of requests when they occur. What about information leakage? The data guard feature in NGINX App Protect allows you to prevent the leakage of certain things from your responses of your APIs or your traditional web applications by either masking or blocking things like Social Security, US Social Security numbers or credit card numbers and things like that. What about the rest of the content of a particular request? You may choose to allow or disallow specific characters as part of a URI or in headers or in a payload as appropriate for your organization. You can certainly do that with App Protect, and we're going to look at the place in the policy you might do that. NGINX App Protect provides protection for JSON content. So if you're using a modern application that uses REST APIs, this is an important consideration. NGINX App Protect can enforce JSON schemas to make sure that an attacker isn't trying to fuzz your APIs by misusing certain types or trying to pass vulnerabilities or attacks as part of those parameters of those JSON objects, perhaps in a post or in a put, things like that. You can also filter based upon methods. You can decide that only certain verbs are allowed for a particular application and deny all of the rest. If you're using gRPC services, NGINX App Protect can also provide protection for those, very similar to how it can for JSON payloads. So let's get back to one of the first features that App Protect provides to defend against attacks, and that's the use of attack signatures. Attack signatures, again, are really thumbprints or patterns for known attacks against web applications. It is recommended that these signatures be updated regularly, but we're going to cover that in a different video. Initially, these signatures belong to multiple classifications or categories. NGINX App Protect calls these signature sets. Out of the box, NGINX App Protect ships with what we call a default policy. And it's a very simple JSON fragment to allow you to be able to provide application protection and usability out of the box. The default policy is meant to be a starting point for your application. And in the default policy, from a signature perspective, we list signature sets that are included. You can see these on the screen here. Signature sets such as cross-site scripting, command execution, SQL injection are of course included in the default policy and enforced. There are other signature sets that are included on this web page, which I will provide in the links, that you may choose to include or exclude from the default policy. Again, what's right for your organization is really going to be important here. So what does the default policy look like? Here, we're looking at the NGINX default policy. This is a small JSON file, which is included when you install NGINX App Protect. As you can see, this is a very small file. What is going on behind the scenes? We're going to take a deeper look at this default policy by exporting this using the App Protect tool. You can use the following command, pictured here, to export the default policy in its full verbose form. We're going to be looking through this full verbose policy to see exactly what is included in a default policy. This isn't designed to overwhelm anyone. However, it can help provide some guidance as to what each section looks like in case you need to modify the settings yourself. Let's dive in. So now that I've exported my full verbose default policy, I can again load it into an editor such as this. I'm using VS Code. And you might notice that I am collapsing each section or each subobject within the JSON policy for readability. So when you load the file the first time in here, you could have upwards of 1,200 lines worth of policy. But we're going to go through some of the key sections bit by bit. You don't necessarily need to have all these sections in the overridden policy. If I flip back over to the standard out of the box policy, note that it's using a template of policy template NGINX base. That means whenever your policy derives from this base template, it will inherit the policy settings from that full verbose default policy. So you do not need to override each individual section if you choose to expand upon your default policy. So back over to the exported policy, one of the first things you'll see is a policy object. That is the root of all policy configurations within this JSON file. Here's where I name my policy. This is important because when App Protect blocks or creates an alert that is logged to an external system, such as Elasticsearch, it is going to include a policy name attribute so that you know which policy was applied per a particular website in case you need to go back and do policy tuning. Next, we're going to see the blocking settings, which includes evasions, HTTP protocols, violations, and other settings. So if an example of an evasion might be an attacker is trying to insert semicolon path parameters or exploit some Internet Information Server Unicode character flaws that were associated with that. The default policy has a list of those particular evasions, and you can see what those default settings are going to be for those. If these evasions are enabled using the true or false, NGINX App Protect will examine the request for them and consider them when trying to determine whether or not the request should be blocked. Next, we have the HTTP protocol sections. Again, this is where we're going to be enforcing protocol compliance for HTTP. So we have a number of cookies to check for, maximum of 50. You can change this, but it happens to be default out of the box. You can change that and enforce that for an application. Again, you're going to need to be very specific as a number of applications emit a large number of cookies. So use caution with all these settings when making changes. Multiple host headers. This is something that we say is enabled as true by default. So when in blocking mode, NGINX App Protect will enforce this. Why should you have multiple host headers present in request? That can indicate that someone might be trying to look for vulnerabilities or bypass certain things, or may not be a real browser that's trying to use your site. So there's a number of settings you can look at here on your own time, but that's an example of where the HTTP compliance settings are for the HTTP protocol. Then we have the violation settings. And the default policy includes a number of names named index is this vial, mandatory header, vial, Medicare. These will appear in the App Protect alert or block log if something has been suspicious and ultimately ends up being blocked. We're going to see how to use these in a future video, but very briefly, the out-of-the-box policy has things like a request maximum length limit. It's something we're going to alarm on, meaning send a log entry out to our logging system as well as block that particular request. Right? But there are other settings, such as parameter value length, that we might send an alert on, but we don't necessarily need to block. There's a number of settings in here you can examine on your own and tweak as necessary in your policy, but that's an example of where you find violations, again, which are necessary when tuning your policy. So that's going to be something you're going to become familiar with as you delve into policy tuning details. Next up, NGINX App Protect provides a sophisticated bot defense capability, and this is the section where you introduce those and tune them. The bot defense setting is enabled by default in NGINX App Protect, and here are some of the settings associated with it. NGINX App Protect has the ability to determine if a bot is malicious, if it's suspicious, if it's untrusted, if it's a browser or something else entirely. And you can tune and train it to be able to detect user agents that aren't valid and things like that. An example of a browser would be Chrome, Safari, Internet Explorer, what have you. Something that is perhaps an untrusted bot might be Postman or the Python requests library or curl. Things that may not necessarily be behaviorally causing trouble, but it's not a browser and might be an indication of automated traffic. So this is something you might choose to disable. An example of a malicious bot might be the Nikto scanner or something related to doing pen testing. And NGINX App Protect is going to block those kinds of things by default. So if it's necessary to do that, you might need to make changes to this so you can include the usage of those tools within your application security program. Cookie settings for App Protect. You can specify the maximum cookie header length. Here it is 4096. Another cookies section where you can determine enforcement of cookies as well as examination of contents. So by default, NGINX App Protect in this policy will decode values as base 64, looking for parameters that might have exploits hidden in them. So that's an important thing that you might want to look at and tweak if necessary, given your application. It's also going to look for those particular attack signatures within the check. This is important that that's set to true. Otherwise, we would be allowing someone to smuggle SQL injection or cross-site scripting attacks through that vector if it wasn't allowed. That setting we looked at there, by the way, is generic, and it's kind of a wild card, the default handling for cookies. But if you needed to tighten up cookie settings or URI settings or header settings by their name, you can certainly extend this cookies array to have particular handling for certain cookies versus others. Data guard is information leakage capability for NGINX App Protect. Not only looking at requests from users and attackers looking for violations, but it's also looking for responses from your upstream applications. It's looking for things like 500 errors that might include stack traces, revealing information you don't want an attacker to know about your stack. It also has the capability, once turned on, to be able to look for U.S. Social Security numbers and credit cards, as mentioned earlier in the video. So something you might want to enable and tune is that data guard feature. In the default policy, it's not enabled, but out of the box, we provide a strict policy wherein it is enabled. So ultimately, you need to decide whether or not this capability is something that is right to enable for your organization. Here's the generic description of the policy. Enforcement mode of blocking. Right now, the default policy will by default provide blocking capability. You can change this to another value of transparent. So NGINX App Protect will still continue to log alerts and things that it would block without actually doing it. This is useful in certain environments if you'd like to introduce App Protect just to see how it would behave without actually affecting what's going on with user tracking. So that's going to be a very important setting that you want to include in your policy and understand what the difference between blocking and transparent is. Enforcer settings. This is somewhat related to meta controls for App Protect. App Protect uses state cookies to be able to track user behavior between requests. You can specify whether you want the HTTP only attribute on for that particular cookie. It issues same site attribute and secure attribute. And the default values are here. File types. By default, there are a number of file types that are allowed and disallowed when part of the request, as NGINX App Protect is evaluating it. There's a long list of files that we don't allow. You can certainly change this if your application requires the request of certain files, but some of the most commonly requested ones that are associated with common attacks are included in here and set to false by default if the file type setting is enabled in the policy to enforce it, and that's contained elsewhere. Now we have the general section, which I'm going to go into. For a given policy, NGINX App Protect will allow only certain response codes. This is apart from the data guard feature, but it's going to examine allowed response codes from your upstream application servers. So here's the list in the default policy of allowed response codes. Now this is besides the 200 and 300 series. This isn't exclusive. But if you find that you need to override or allow additional 400 or 500 series response codes, you would add it to this array here. So again, this isn't complete, but again, that's in addition to the common ones you would expect to see within the 200 and the 300 series. You can also choose to mask credit card numbers in requests as they come in and trust an X forwarded for header. This is important if you are using NGINX App Protect behind a downstream proxy that might change the source IP address of the request. So if that is the scenario and that downstream proxy is changing the address, it's going to look like from App Protect's perspective that all of the good traffic and all the attacks are coming from the same IP address. You definitely don't want to do that. So if you are using a downstream proxy, you want to configure it to insert a header such as X forwarded for and enable this setting so that NGINX App Protect can use that header that is being injected by that downstream proxy as its source address of the attacker or visitor when doing its enforcement as well as reporting out in logs. Here is where we're not going to go into it deeply, but you have the capability to set and apply different signatures or create exceptions for headers, cookies, URLs, or other entities. You might choose to allow or disallow repeated occurrences. The decoding of those, automatic decoding of base 64 things to look for the source values that were encoded in there. You can also set certain parameters or URIs as mandatory. You can normalize them. You can allow violations when certain URIs are present or not present within your policy. So a lot of flexibility. Now, I might add that whenever you make these kinds of changes, you are making your security policy very likely more secure, but you're also going to be incurring an amount of maintenance overhead as you enable a lot of these things. So in organizations that choose to add very specific positive security settings like this, you're going to need to have a very tight relationship with your application developers or your application vendors in case there's a change to that application that might produce what we call a false positive when applying a policy such as this. So again, the control is there, but you need to be cognizant of the impact that it can have in production once your application changes if you're using these very tight entity settings. We talked about JSON profiles earlier, and we can talk about XML profiles in the same way, but there are some settings related to the handling of XML or JSON body content. What are some of those settings? Well, we have the ability to say whether or not we want to scan those looking for particular attack signatures. By default, the policy is set to true there. We have the ability to set volumetric constraints on what we allow to post within JSON or XML. The total structure depth, how nested objects are, how large arrays are, things like that. What happens if it cannot parse the JSON payload? Should we respond as if it was an attack, or do we allow that sort of thing? There's a lot of control overall in terms of specification enforcement and well-formedness of JSON or XML policy files. But in addition to that, if I have a JSON schema file, I can introduce it to the policy, and NGINX App Protect will create a very detailed policy for me describing the shape of the objects for my application, and it can enforce the settings. So for instance, I can introduce my schema to NGINX App Protect, and for every object that's in that schema, it will enforce the object's type, the names of the objects, the children associated with it, and whatnot. Again, creating a very tight policy without needing me as the policy author to go in and create all of those very specific entity settings we talked about earlier. So I would encourage you, if you have access, reliable access to an up-to-date and current JSON schema file that describes your application or your APIs, we encourage you to attach it here within the JSON policy. In addition to that, NGINX App Protect has the ability to attach an OpenAPI file or a Swagger file that will fully describe not only the schema of the request and response from your application, but also the URIs and all of the parameters associated with the usage of the applications. Again, we recommend you use those because if I have an up-to-date version of a Swagger file or an OpenAPI file, I can just attach it to the policy without having to build out all the individual positive security rules as contained in some of the other sections. So that is definitely a good practice if you've got a modern application where you have that contract file that you can apply to NGINX App Protect. This is also going to apply to gRPC services. So if I've got an IDL file, which might be contained in a protobuf version 3 file, describing the services for my application, describing the binary payloads, I can attach that to the policy, and NGINX App Protect will happily enforce those for me without me having to go in and manually create positive parameters for every policy setting associated with the usage of that service. There are additional settings here associated with methods. Again, if I'm using an OpenAPI or Swagger file, these methods will be specified by that. But if I need to set these manually or I'm using a classic application, this is the list of the allowed HTTP methods or verbs for the default policy. If there's something I want to remove or need to add to this list, I can most certainly do that in my policy. Again, I wouldn't be modifying the default policy, but I would be wanting to modify it in my own version of the policy that I'm going to maintain. Response pages. If a request is such that NGINX App Protect determines it needs to be blocked, it's going to respond with a default response page. And out of the box, it is going to be a traditional, a very white blank page with a support ID attached to it. But I have the ability to override that. So for an API, a REST API, it might not, of course, it wouldn't be appropriate to respond with HTML markup. I would want to respond with JSON, as well as an appropriate status code in the event of a block. So my user and my consuming application knows what they can do with that. It'll be valid markup. I can certainly request those, I can create those response pages here and override any of those settings in a way that's correct for my application. Another reason I might want to do that is I might want to specify corporate branding or images or other things that are appropriate, again, to create a unified experience while using NGINX App Protect. So those settings and those action types are located here in the default policy. And again, I can certainly respond with my own own response page type and attach it to my policy if appropriate. So you can find all that in the response pages section. Again, you're going to see more detail in the NGINX docs online. I can determine what a sensitive parameter might be in my for my application. So how is this used? So when NGINX App Protect is logging to a third-party system, such as ElkStack or Splunk or Syslog or whatever, it's going to include elements associated with that request for further analysis. So some of the things that might occur or might show up in that kind of a in the third-party logs are going to be the request, the headers, some cases body, and whatnot. Now in those might be what we would call sensitive parameters, things that you don't necessarily want to disclose to third-party logging system for compliance reasons. So out of the box, NGINX App Protect will scan for certain parameters associated with a request. This one by default is password. And if it sees a parameter literally called password, it will mask it out in the logs so as to not disclose that downstream inadvertently. You can add additional sensitive parameters given for your particular application to this list, and NGINX App Protect will also mask those in downstream logs. So this is something important to be aware of. Signature sets. We talked about these a little bit in the default policy. A number of signature sets are specified by classification. So we have XML external entities, CVE signatures. These are important, related to vulnerabilities as they occur. That's one group. Denial of service signatures. Again, there are categorizations of these fingerprints, if you will, of what different requests look like. The default policy for each of these sets has configurations to alarm on them or block on them. So most of the signature sets in the default policy are set to alarm if an individual signature is triggered and evaluated all by itself. However, we have some signatures that are very high accuracy and low false positive, meaning if a request comes in and it contains something that is unmistakably someone up to no good, an attack, we call that a high accuracy signature. So what we're going to do in the default policy is absolutely block it. Signatures can be in multiple signature sets. So for instance, if I have SQL injection signature, it's going to appear in this pack, but if also classified as high accuracy, it's going to be in this signature set. I said pack earlier, I meant set. So what does this mean? Does this mean a SQL injection signature is never going to be blocked? That's not the case. Signatures, as they are triggered, have a cumulative effect, and NGINX App Protect decides whether or not they're going to block a request if it contains one or more of those signatures, right? Signatures can also occur, as I mentioned, in multiple sets. So I might have a very obvious cross-site scripting attack, putting a script tag in a URI, a beginning script tag or an ending script tag. That may be in the cross-site scripting signature set, but it is also very likely in the high accuracy signatures set. So that would most definitely be blocked. So most of your policy tuning has to do with the handling of signatures. So if you determine that a particular signature is inadvertently blocking application functionality, or you always want to enforce a certain signature, that is going to require you to make a change to your policy. And that's, again, something we're going to be walking through as one of the scenarios in an upcoming video related to policy tuning. So that was a quick tour of what's in the default policy. For details associated with each section and how to configure them, please refer to docs.nginx.com in the NGINX App Protect WAF section. Thank you for joining me in this initial installment of the policy series. In an upcoming video, we're going to show the policy tuning process. What can indicate we need to make changes to the policy, and how do we make those changes? Stay tuned for the next video and we'll walk through those scenarios with you.